Hello students, how are you? In today's example, we are going to discuss the concept of gradient descent function, right? So you can see the example here, and we have to find 100x. So if we find out the range of x, then we can predict from where to where 100x is lying, and from there we can get the answer. So this simple property is very useful here, as we know that box of x lies between x minus 1 to x when x is not an integer. When it is an integer, it will be equal to this, right? So we can say that this term box of x plus 0.19 lies between x plus 0.19 to x plus 0.19 minus 1. This property is very important. This can be used in sandwich theorem also for many question of limits in JEE. The next term will be this, and this. If we go on doing this, the last term we have here is x plus 0.91 x plus 0.91 to x plus 0.91 minus 1. If we add all of them, then x will get added from 0.19 to 0.91. So there are how many terms? Basically 19 to 91. So 91 minus 19, but we are adding 1 to include this number also. So we will get 73 terms, right? So this x will get added 73 times, and we will get 73x, and this point, similarly this 0.19 will get added in this form. Sorry, it's 0.20, sorry, 0.20 up to 0.91. Then this term will get added, and we know the addition of this term is 542, and then this term, this x will get added, and we will get the term 73x, and here this term is added, we have here minus 1 also. Minus 1 will also get added 73 times, so we will get minus 1 minus 1 minus 1 to up to 73 times. Here 0.19, 0.20 up to 0.91. Just to save time I have calculated this all over. This will become, if you calculate these values, this 73x, and if you solve, if you add, basically this is nothing but an AP, right? AP. So there are 73 terms, 73 by 2, 0.19 into 2a, 2 into first term, plus 73 minus 1, d is 0.01 minus 73, 542. Similarly 73x, this is the same term here, to a is AP, right? Twice of first term, same 0.19 plus 73 minus 1, 0.01 difference. So if you solve this term, this term is less than 542, and by sending all this term and 73 here, you will get that x, by keeping all this term here, so you will get that x is less than 7.88. and if you solve this term by sending this term on the left side, you will get that x is greater than, right, x is greater than 6.88. so we'll get this term. So we can say that x lies between 6.88 to 7.88. we'll get this number. So we get the range of x, but if we multiply 100 here, so we will get 688 to 788. So the box is not we are not able to get the greatest integral function of 100x because the interval is quite big and there are many integers in between. So this interval is not enough to get the answer, but this will be useful. Now as we can see that x is greater than 6.88 and 0.19 is getting added with it. 6.88 plus 0.19 is something 6 point something, right? So we can say that, as we don't know the value of x also, but we can say that when we add 6.88 plus something, we will get 7 here. Many 7 will be there because in the greatest integral function there will be something greater than 7, and if the value of x is nearer to 7.88, as we don't know about it, the greatest integer function value will become 8 for some. If we consider, let there are n number of 7 here, so this equation will become 7n. So automatically there will be 8, as there are 73 terms, the remaining will be 8. As we put 7.88 plus 0.91 is 8 point something, there will be 8, right? But there will be no 9. So we can say that if there are n number of 7, then we can say that there will be 73 minus n number of 8 here. So if we add them, you should get 542, correct? So by solving this, we will get n equal to 42, right? N equal to 42, we will get n equal to 42. So what we get here, that n is equal to 42, means that there are 42 terms which are 7 here. So if we check the 42th term of this, it means there are 7 7 7 7 7 7 up to 42 times, and then the remaining are 73 minus 4, there are 8 terms, 8 8 8 8 remaining terms. So what we can see here, let me go to the second page for the calculation. So what we can see here, that the last term of the question, as we are getting 7 7 7 for the 42 times, the first term was x plus 0.19, this is 7 up to the 42 term, which would be x plus 0.19 plus 42, right? So we can say that x plus 0.19 plus 0.41, as it is starting from the 0, if we go from 0 to 0.49, there will be 42 terms, right? So we can say that this term x plus 0.19 plus 0.41 is becoming 7. It means that it is less than 7, sorry, it is less than 8, that's why it's becoming 7, and it is greater than 7 obviously. So we can, after calculating, we will get that x is less than 7.4 if you solve this. Similarly, the next term of this, from this we are getting 8 8 8 8. The next term is x plus 0.19 plus 0.42. this term should be greater than 8, that's why we are getting the box 8 here, greatest in function value 8 here. So this term, the next term, which is x plus 0.19 plus 0.42 should greater than 8. So what we will get, that x is greater than, if after calculating, just to save time, we will get this number, right? And we will get this number. So we can see that x lies between 7.39 to 7.4. If we multiply 100 with this terms, we'll get 739 to 740. So the question was about what is the value of box of 100x. If you remember, the question was what is the value of box of 100x, gradient descent function of 100x. So it will become 739. So the strategy we use, we try to find out the value of x from where it lies. Well, first we get the value of x, but that value was not sufficient. Okay, that value was not sufficient to find out the which we get here. This one was not sufficient to get the answer, so we use this interval to further solve it further, and then we get the another interval, that is this one, and this is was sufficient for us to get the answer, right? So I hope you understand the question, though question is quite lengthy one, but it is doable if you know the basic concept of a gradient descent function. Thank you.